what the shit this is. Giving myself a benchmark. So, let's say you have a football team. Doesn't really matter if you don't like football or not. I know you know the basics. People run around, there's a ball going up and down. That's all you gotta know. So it doesn't make sense. If your football team, nobody on it's very fast. They're all really slow. You guys with me? Yes, yes, yes. What are you probably trying to look for in the next person you bring into your team? You want somebody fast. So maybe they could be the punt returner or something, or they can just run around and confuse the other two. Whatever. Right? You need some fast person. So aren't you going to set a benchmark for all the tryouts that you want them to run a certain distance in a certain amount of time? So you want to show me evidence you should be on my team? I need you to run this fast or more. Right? Do you guys see what I'm saying? You're going to set a benchmark for showing me evidence that you should be on the team. So you got the average speed of your team. You don't want them just to be faster than that. You want them to be really faster than the average, right? So you set the benchmark and you go, I'm going to consider you if you show me evidence you should be on the team. Get past that benchmark. You guys semi with me? Even if you hate football, you still get the idea, hopefully, right? Okay. So this step is that. It's saying, okay, I know I want to be bigger than this, but how far away do I need to get? And right now, what do we accept to be how far away before unusual starts? How many steps away? 2 steps away. I told you way earlier this semester, like a week or so ago, that we were going to adjust that based on the situation. Like if I'm in a nuclear power plant, I'm not going to make it 2 standard. Here's normal. I'm not going to wait for it to get 2 steps away from normal. I'm going to get off my ass the minute it's like half a step away from normal. Right? You guys with me? A little bit? I don't want HBO to make another show about me 20 years from now because of what I did, because they didn't get off my ass. You went. Whereas if it's just something that doesn't mean as much, like you're trying to show somebody at a fair is able to guess somebody's weight and you're setting up benchmarks, who gives a shit if you're not quite right, right? So you don't have to make it 2. You can make it less than 2 steps away. Stay with me now. So if my claim is the percentage of people like hypothesis test is at most 42%, to show evidence I'm wrong, I've got to be so many steps away. So now we got to figure out what's going to tell me what that is. Normally it's 2. But now, depending on the problem, it could change. So everybody got their T-score charts. Uh-oh. Cool. You need one. Here's one. Yeah. Let's do for this one, yeah. We put it over here. Let's say that alpha is, what do you got, Joe? I don't know, Joe. Alpha's 0.01. Let's say I already figured out that I could use Z-scores. Everybody with me? So if alpha is 0.01, what does alpha mean again? Does anybody remember? It's a little fish, and fish have what on the end of them?
Oh, the tail.
There you go. So the alpha tells you the area of the tail or tails. This problem, we already said it was a how many tail problem? 1 tail problem. So 0.01 in 1 tail. Do you guys see that? Doesn't that kick ass? That T chart is set up for hypothesis. I know it's a 1 tail test, so guess which row I'm going to look at? The top one, the one that says 1 tail. You want 0.01 in there. How do you get the Z-score from that T-score chart? Use freaking magic. No. You go all the way down. What do you guys get?
2.226.
So what does that mean? If they tell me that they want alpha to be 0.01, and they might use this phrase. I don't know if I haven't used this phrase yet for alpha. It's called the level of significance. Yes, ma'am. Go ahead. All right, let's do that again. Look at your T-chart. So one tail test with 0.01. Do you see which column to look at? One tail test, 0.01, 2.326. I like it. You guys with me? Now just remind you guys, confidence intervals were always two-tailed. You can cut it in half if you felt like it. Hypothesis tests are kind of nice. They are very, it's 1 or it's 2. Bam. I like it. What does this mean? It means in order for me to prove that my claim is wrong, I'd have to get a sample with a z-score more than this. If my sample was way out here, I really want this to make just intuitive sense. Does it mean that if my sample's way out there, could the actual middle be there? More than likely, no. What's the chances that I'll get a sample in here? Can anybody tell me that? I already wrote it up on the board. What's the probability that I get a sample in here if this is the right middle? If that number is in the right place? What's the chances I get a sample out there? You know what it is? No. 1% chance. Because what's the tail? What's the area of the tail? 1%. So now think about that. Now think, come on. If 0.42 is in the right place, and I get a sample way the shit out here, there was only a 1% chance of that happening. So what's more likely? 0.42 is in the right place and I just happen to get a sample up there, or it's in the wrong place, it's actually bigger. What's more likely is it's actually bigger. And again, with statistics, there's a 1% chance you're wrong, which is better than normal for most of us, right? So that's pretty good. So that level of significance is related to the amount that will make you get off your ass in a nuclear plant. I would make it like 0.10 for a freaking nuclear plant. 10% chance I'm wrong is even that's not good enough, right? Maybe. But if I'm trying to show evidence to an insurance company that the new fire station, they get to my house faster, the insurance company, so that my rates go down, they're going to make alpha really small, so it's really hard for you to prove it because they want you to keep paying a lot of money. So you can take a sample of times they came, you can show that it's less than, but the insurance company is going to be like, it's got to be like really less than before we lower your rates. Does that make sense? So this is why alpha is variable. It's not the same for every problem. It depends on the situation and who you're trying to prove something to. Another name for the fishtail dude is level of significance. Because the smaller that number is, if you pass the test, it's more significant. It's a higher level that you've passed it at. Raw.
Did you get 0.01 from the...
I got that from the problem. They have to give it to you. Okay. The problem has to tell you what level of significance to use. That so has to be given to you in the problem.
So in our case, do you have it or you provide it?
I'm making the problem up as I go. Okay. So this shit is wide open for me.
Okay.
When you hit a problem that I give you or the book gives you, they have to tell you what that is. Okay. And there's a section where they just say use 0.05 everywhere. Because 0.05 is the most often used one. We know that. That corresponds to our 2 being unusual for the most part. Maybe. This is freaking, yeah, it is. All right, so I want, this is what we call, the official name for step 3 is finding the rejection region. It's not the same as the friend zone, but it is related. Not completely rejected, just semi-rejected. So the rejection region, why do we call it that? Somebody, let me see. I know I've talked a lot today, and most of what I've said maybe didn't make the most sense, but if I did find a sample that was in the shaded area, that's the rejection region. If I did find a sample in there, I've seen a movie theater, if I did find a sample in there, what can I say about this guy? See if we can put it all together. What can I say about this guy? If I find a sample way the shit up there, it looks, no, don't say it's true. That's evidence for it being correct, right? It's not proof, you can't say it's true, but I can support this. Which means, what about this guy? He's the opposite. So I could probably reject him. That's why we call it the rejection region. If I get the one that thinks it could be equal to, right? That's why we put the equal to in the hope. The one that thinks it's equal to looks like he's wrong. I can reject him if I get so frickin' far away from that. That's why we call it the rejection region. It's where I can reject. You could say it like that, sure. Probably a better way to say it. Reject the null instead of reject the hope. Support the high. That's why I like the high. It was nice. Support the high. Yes?
So what if the null is right and the null is wrong?
Ah, I love it. Behind all this shit is the possibility we're wrong. Are there people on death row that are innocent? We know this is true, right? I'm not going to get into any political whatever shit, but that is just a known fact. I'm not saying what to do about it. I'm just saying we know that's true, right? Why is that? Because a court case is just like this shit. What's the null hypothesis in a court case?
You're not guilty.
Yeah, you're not guilty. And what's the alternate hypothesis? You're guilty. So what's the prosecution trying to show evidence for? That you're guilty. That you're not innocent, that you are guilty, right? So they have to show so much evidence that it's more likely you're guilty than not. Does that mean that everybody that's found guilty is actually guilty? No. Why do we live with that shit? Because we got to have something, right? Which is why, anyway, I'm not going to, I almost said some stuff, but I'm not going to go any opinion. Okay. Let me bring it back to where I was. So, this is just like any court case. It's within a reasonable doubt. It's just like real frickin' life. Very few things we can prove absolutely. We just have to show enough evidence for something or against something, right? So that's the way anything works. I like it. Okay. All right, so that's why this name kicks so much ass, because it kind of reminds you what it does. So I set up the rejection region, could be one tail or two tail. And then what do you think I do next? If I say, well, my sample has to fall here or one of them, the next thing I do is see where the sample went to. So the next thing is to calculate the Z-score from the sample. All right, by this point, we've got to do a specific problem or else we're going to go insane. Calculate the Z-score from the sample. Let's see where it fell. All right, so let me give you this handout. Wherever it is, here you go. So let's do this handout and then we'll probably take a break. Got two colors on this one. This is a pretty colorful one too. I should have turned this on. Too bad. Okay. There you go. There you go. Okay. So, Phil the researcher. That's not an instruction. Yes?
On step 4, when you calculate Z-score, is it calculate Z for the Z-score depending on what you get?
Yes, I like it. This problem, I think it turned out to be Z. Real quick word about that. As a statistician, Z and T are the same damn thing to me. So I will sometimes say Z when I mean T or something. I know that kind of sucks. What do they both measure? The number of standard deviations away from the mean. So to me, I wish there was just one word we use for that idea. And sometimes we call it a Z-score. Sometimes we call it a T-score. Anyway, so I'll try to be careful about it. Let's go through this problem. Can you guys take a minute and do the first step? We should be able to do that first step now. Pretty good. So I call this H1 material. Big deal out of this. Which number am I giving you that won't show up until way later in the test? Which number would not show up until step 4, to be honest?
So, that's a weird mean? 7.25.
No.
8.65.
8.65. Because that came from the what?
The sample.
That came from the sample. So and that's not going to be until step 4 here, right? So my claims, my hypotheses, always have to be related to some known thing, not something I get from the sample. That comes later. So I have to give you all the information, and normally we don't even know the sample until I get to step 4. That's when I go take a sample. All right, so what's my claim? I was really, really nice here. Don't get used to me bolding all the important shit, but I did. So what's the claim? I don't want English. We're in math class. Sprechen Sie Math. Mu? No. No. I heard it over here. Lives longer. That's the claim, right? They live longer. So mu is greater than what? 7.25. You guys with me? So let me see if you guys see what I mean about this. When you see directional words, it's going to be a one-tailed test. Longer, more than, increased, that's all great. Decreased, went down, that's going to be less than. When you don't see directional words, it has got to be a two-tailed test. I'll bet you anything. Anyway, we'll see an example of that in a minute. Which one does that go in for? Which one? Does it have an equal sign? No. So which one does it go for?
High.
The high, right? Or you can make that an A there. I know. It is a 1 because that's what it was for another one. HA. So HA is going to be the claim. Remember, the claim could go either one, right? If the claim has an equal sign, it goes in for the whole. What's the null hypothesis then? Less than or equal. So is it a one-tail or a two-tail test? Yeah, one-tail. I can see it right there. In fact, what side is it going to be on? Yeah, greater than. So it's going to be up here. Don't make that more than it is. It's that simple. So it's a one-tail test. So I'm trying to, in black, I put sort of the idea. I think the red is the idea. I can't remember what the show was. Can we use ZT or nothing? Why Z?
Population standard deviation.
Say again?
Population standard
Yes,
deviation.
we know sigma is known. What's more important than that? What has to happen so I can do anything? Why is it normal? Does it say so? Yeah, it is. And it's 41, which is bigger than
30.
30. Check. Check. So I can use Z-scores. So is it normally distributed? You got to see. Does it say it is, or is the sample size big enough? Or if it was a percentage problem, what do I check? NP, NQ greater than 5. I like it. So it depends on the situation, how you tell if it's normal. But the requirement stays the same. It's got to be freaking normal. For the means, which standard deviation? No, in this case, the population one. I made that really clear with it's blue and bolded and all that kind of shit. And again, I'm not going to color code your answers for you. Normally. Okay. So this is a one-tail test. We already did this, didn't we? So it's one tail up here. Alpha's 0.01. So what's the z-score I put right here? We already did it, but we can do it again if you want to. Yeah. Shade that bad boy in. Now, real quick. I didn't get to much on 4 yet, but that's a z-score, right? Right? Or it could be a t-score. On another problem, I could use a t-score. Whatever that is, that's what that is. The next step, I'm going to calculate, in this problem, a z-score from my sample. So to distinguish between the two, me, you're not going to see this anywhere. I made this one called z-star. And you'll see I put a little star on it when I put it on my picture so I can see where I fell. So when I say z-star, I mean calculate that from the sample information. So this step is what's good enough evidence? And then the next step is, did we find enough evidence? I like it. So can I say this in words? When am I going to reject the null if my z-star is where? Where's the rejection region? So if the z-star is greater than 2.326, we can reject the null, support the ha, or the ha now. I'm going to get used to that again. Please, I'm just showing the same information in 2 different ways. One is visually. That's what I mean when I say define it visually. Put it into words also, like that. Just so I really can see that you know what the hell you're doing, really, and to help you out, hopefully, in the next step. All right. So this is, what are we talking about? What can we use to talk about it? What's enough evidence? Did we find enough evidence? What do we see from the sample? What's X bar? 8.65. What's sigma? 3.27. I like it. What's N? 41. What do I have to do with that? Before I can make a z-score, what do I have to do? Let's see if you guys get this. I think I hear it. Find the new standard deviation. Yeah. So what's the new standard deviation? It's going to be L1 divided by the square root of 41. Whatever the hell that is. If you need a calculator, you should get it because you're going to need it pretty soon. 0.51. 0.51. 1, I guess. 1. Oh shit. Yeah, 0.511. Everybody got that? The 0.51? Okay. That should be old news to us by now. We've done it so much. No, let's do it. And now I can make my z-score. I claimed this earlier this semester, and it is a true statement. Z-score formula never changes. It's my data, 8.65. And here's something I haven't said yet about these things. I really want this to make sense. All right. This sort of came out in my discussion earlier, but the way hypotheses tests work is we assume this is the right middle. This is what I was talking about earlier. Assuming this is the right middle, if I find a sample way the shit out here, that's a contradiction. If that's the right middle, where should any sample show up? Most of them should show up close to 7.25. Right? And in the process of doing this problem, we have defined what not close is. So assuming this is right, if I manage to do this, look at that. So have you ever heard that? Assuming you're right, look at that shit, right? It's like nobody ever wears green here. Assuming you're right, look at that dude wearing the green shirt. What the shit? You've heard this kind of phrase, not very often, but still. Assuming you're right, look what I can do. Holy shit. So we always assume that the number from the claims is the real middle. Because what we're trying to show is, if we assume that to be true, can we find something that contradicts that? So what's mu? 7.25. We're going to assume that's the right middle number. Divided by what? Yeah, the new standard deviation. So somebody help me out. 2.77.
5.
2.75. So make sure you get that, and make sure I get that. .74. Yeah,
2.745.
4. So I get this here. Is it very cool? All right, now where is that on the picture? That's my Z star. Where's that on the picture? It's way up here, right? Put a little star on it. So did we succeed? Did we make it? Yes, we found evidence to say what? Let's be a little less specific right now. I can do what with the ho? Reject it. Good job, guys. And what can I do with the high or the ha? Support it. Now, real quick, if I did not make it in there, I would fail to reject the null, fail to support the ha. So either I make it or I don't make it. You gotta love that shit. Do you guys see? Does it look? It looks like I wrote two things. These are both the same. If I can say one dude's wrong, that must mean I think the other dude's right. Now, okay, let me stop here for a second. Aren't you happy there's not 8 steps? 5 steps is enough, yeah? Okay. All right. What was I about to say? Oh yeah, okay. It's already semi-decent. I mean, I know this is brand new, but I hope you see every step is really built on shit we did before. We've just never put it together like this. Which one was my claim? The ho or the hot? Or the hot, sorry. Which one was my claim? Which one was my claim? This one was my claim, right? So then how do I want to word my conclusion? I want to use the one related to the ha. I want to use this language right there. Always. If my claim would have been this, the ho, I would have used this language. But it wasn't. So shouldn't my conclusion talk about the claim? As soon as I claim this, go test it, and they come back and they tell me something, I'm like, what about my claim? Talk about my claim. Shit. So, what's my conclusion? Did we find evidence or not? We made it. So we have found another paragraph, Jeff? Yes. Not really, it's one sentence. Jeez. We have found sufficient evidence. 2. This is where this word comes in. Now I know I'm going to use this language here, right? To support. Don't you be putting no ha here. Put what the hell it is. What was the claim? To support the claim that what? What was the claim? There's a million different ways to state this, but...
Coyotes live longer in captivity.
Beautiful. I love it. That coyotes live longer in captivity. You could say that the average lifespan of coyotes is greater than 7.25 in captivity. You can be very specific. You've got to capture the physical reality of what it was I was looking at. Coyotes live longer in captivity. Or, you know, you can be more specific on the type of coyote. As long as you bring in what the physical situation was in your conclusion, I'm happy. Woo!
How about if you use signs? You need to write evidence, or I can use like figures. Like, can I say you have found evidence, and then I say 7.56?
Oh, sure. Like I just said, we found evidence. You need to say we found evidence to support or reject. That's important. The claim that, and then whatever comes after that, there's a million different ways to say the same thing. You can bring in the numbers that the coyotes in captivity live, have lifespans greater than 7 point whatever it was, right? Or you can use just pure English like I did, right? As long as you capture the idea of what it was you were testing. Don't just say support the claim or support the ha. What does that do? How'd it go, Johnson? What do you find out? I supported the ha. Okay, shit. You laughed. What's going on? So actually bring language in about the claim. Okay. Yes.
Okay, so for the level of significance, so whenever you get it, is that level of significance always rejecting the hull or the null? Is that always going to reject the null?
Whatever this Z-score is, right?
It's always going to reject it.
When I get further than that, then it's going to reject the null. Yes. So the reason we always put the equal sign here is so that it can always interpret this the same way. That's why the claim could fall here or here. So whichever one has the equal sign is the one that looks to be wrong. Because what does this guy think? It thinks it's in here somewhere. Because it could be equal to 7.25, right? So we find something out here like we did, then it looks like whoever thinks this is wrong. So that's why I can reject the null. Because the null is always going to have the equal option. Okay, guys. Let's take a break, and then I've got, not surprisingly, more worksheets and examples of this to work on. Yay!